let's just take a look at these notes, see what we did last class and what in the world we're doing this one. So we started a new type of question. So basically, we're still doing confidence intervals, but we're doing a different type of like question. They're going to give us different types of information. And the question is like really similar, right? So it's basically what we did last week, but instead of given the population standard deviation, we're given the sample standard deviation. That's really the only difference between the two questions that we're doing. Now, finding the critical values is a little bit different because instead of using the small chart, we're instead using the big chart. So that's another kind of difference that we did. And the standard error formula does look a little bit different, but it's still the standard deviation over the square root of n. So it's still the same thing, except there's a very slight difference in the process that we do. Okay, we did a couple examples of like using the big chart. And then finally we got to this procedure. I took out step 2 because I'm never going to ask you to actually find the sample mean and the sample standard deviation because that just takes a lot of work. But you're going to check your assumptions. The assumptions is now we're looking if S is given, and we're also looking if the sample size is big or the population is approximately normal. That stays the same. Step 3 is finding the degrees of freedom, which is the easiest formula in this class. Just take sample size -1. You're going to use the big chart to find the critical value. Step 4, find the standard error, and then all the rest of the steps are exactly the same as we've done before. All right, so we started example 1, and this was the one where like the food chemist was trying to find out how many calories are in the type of cookie for some reason. They took 8 cookies and found the sample mean, the sample standard deviation. We know that it's approximately normal, and we want to find a 98% confidence interval. Now, at the end of last class, we did go through some of the symbols. We found that n was 8. We found the sample mean, sample standard deviation, and so on. That's basically all we've done with this problem. Let's actually just go over how we finish up the question. So let's go through the assumptions here. The first one asks us, is S given to us? Well, it definitely is, right? S is given to us in the question. It's 2.825. So, okay. The next question is asking us, is the sample size bigger than 30 or is the population normal? Is their population bigger than, or is our sample bigger than 30? No, right? Our sample size is 8, so 8 is less than 30. Does that mean we can't do the question? No, right? What in the question tells us we can go on?
States that the population is approximately normal.
Yeah, it says the population is approximately normal. So even though this is true, the population does, it does say the population is normal. So because of that, we can say, yes, we can go on. All right, here's where things get a little bit different. We need to find the critical value using the big chart because we have a question that gives us the sample standard deviation instead of the population one. But before we go and look at the chart, we have to find the number of degrees of freedom, right? So does anyone remember how we find the degrees of freedom? Claire?
N-1.
Yeah, it's the easiest formula in the class. It's n-1. So we're going to take 8, which is n, subtract off 1, and that gives us 7. Okay. The degrees of freedom gives us what row we're looking at in the chart, right? So this is the row we're going to look at in our chart. Okay. Going all the way to the back here, I'm actually going to kind of erase what I did last class so it's not very confusing here. So let me just erase all this. Okay. We're going to look at row 7, right? So looking at row 7. And then the column is kind of weird because the very top of the descriptions of what the columns mean, it doesn't really tell us that much. But what we do is we have a little cheat in the bottom, right? And it says confidence level. We know that we're looking at a 98% confidence level. So we're going to look at this column here, which is not trigonometry. Okay, there we go. Our 1, 2, 3, 4, 5, 6 column. So we're looking at column number 6. Going back to the front, we're looking at 1, 2, 3, 4, 5, 6. We're looking at this column here. Okay. All right. Well, where those two intersect is 2.998. So that's our critical value. 2.998 is what we're looking for. Any questions on part B? All right, let's move on to part C here. This one asks us to find these, oh yeah. Oh, yeah. I'm, oh no. I hate it when that happens. Yeah, I also tend to write really fast when I'm talking. Okay, do we have any questions? Oh, yeah. Do we have any questions so far? I think we're all good. All right, part C, we need to find the standard error. Does anyone remember the formula for standard error? Claire?
S over square root of n.
Perfect, right? So it's literally the formula we had from last week, but instead of the population standard deviation, we're using the sample standard deviation because, well, that's all we have. Okay. So S here, if we take a peek at our list of things, it says S is 2.825. Looking back at my notes, N is 8. So I can put 8 here. Okay. And just a little note, I saw some people putting the degrees of freedom underneath the square root. Make sure you're actually putting what the question gives N is here. So instead of 7, we're writing 8 on the bottom. Okay. All right. If you don't have a fancy calculator, I do recommend doing the square root of 8 first, which is what I'm going to do. 2.828, the square root of 8. And then if you have one of a non-fancy calculator, you can go ahead and do the division. And that gives me 0.999. Okay, so that's my standard error. Next, we have to find the margin of error, the MOE. Does anyone remember how we do that? Oh, that's the next part. You're almost there. Yeah.
It's a standard error.
Yeah. So this is before we added subtract. But good try there. So the standard error is the 0.999. The critical value from part B was 2.998. Okay, so we're just multiplying the two numbers that we just found together. And that gives me, gosh, 2.995. All right. Now that we got the margin of error, now how do we do the confidence interval? Claire?
The sample and
Mhm.
plus or minus 2.995.
Perfect. So this is where we add and subtract. So we're gonna take the sample mean, which is our point estimate, that's what we called it. We're going to add the margin of error and then we're gonna subtract the margin of error. Okay, taking a look at my notes here, X bar was 115 point whatever. So I'm gonna take my 115.375. I'm going to add the 2.995. I'm also going to subtract the 2.995. And the two numbers I'm getting is 112.4. I don't know why I didn't leave 3 decimal points that time, but this is fine. And then my other one is 118.4. Okay. So once I find my two numbers, you can stick them in the interval. Usually the lower one goes first and the higher one goes second, but it doesn't really matter to me. And once we're here, is there anyone who wants to guess how to write the conclusion? I see Eric.
So then we are finding
Or confident, but yeah. Uh-huh. Yeah.
that is between 112.4.
Uh-huh. Perfect. All right, so same conclusion as we've been doing so far. Great job on that. Is there anyone who has a question on anything that we've done so far? All right, I know that was a lot of writing, so I'm going to keep this up. But if you flip to the back page, I have another example. Why don't we try this one? So I'll give you a few minutes to work on this. We'll come back as a class and then we'll do our quiz review. All right, let's come up to the front here and just go over this real quick. So here we had a bunch of people and they reported the amount of time they spent on the internet in an average week. Now, if you've never looked at your screen time on your phone, just don't do it because it's kind of scary. My screen time is definitely not like 9.84 per week. I think it's a little bit more than that. But maybe that's just me. All right, so first I asked everyone to write down the information, and I think I forget who wrote this one up. Oh, Ariel to write this one. Now, I'm not gonna make you explain that one, right? Oh, no. All right, but Ariel did a great job of writing up all the information up here in a very organized way. So great job there. Next, I did the assumptions. Now, who wrote this one up? McKenna, I guess I don't really need you to explain this one either, right? S is given and sample size bigger than 30. Great job there. Part B, was that one, Ashley? Yeah. Ashley, do you want to kind of explain this one? Mhm. Perfect, right? Now, there was no row for 122, so we used row number 100, right? I'm just going to ask you a quick question here. What if the degrees of freedom, and this isn't the question, so you don't have to write this down. What if you got like, I don't know, 199 as my degrees of freedom? Which row would you use here? Still 100, right? So we're not like rounding down and rounding up here. We're always rounding down to find the row that we're using, okay? So we'd still use row 100 here, okay? So doesn't really matter if we're closer to one number than another, we're still rounding down. All right, let's go to part C. Who wrote this one up? Is that one Claire? Do you want to take us through this one? Oh, sorry.
So I would use standard error, which is sample standard deviation
Mhm.
over the square root of population event.
Yeah.
And that equals 0.887,
Mhm.
which I then used to help figure out the margin of error along with the critical value we got earlier in the chart to equal 2.0.
Perfect. Great job there. Then we went over to the confidence interval. Savannah, you want to take us through this one?
So you take the sample mean and subtract the margin of error.
Perfect. Now I know some of you got different like rounded numbers. As long I don't really care about rounding, as long as you get the right steps and the numbers look pretty accurate, then that's fine. All right, and then finally, why am I what I want to call you? There's a McKenna and then there's Michaela. You're McKenna, you're Michaela. Okay. Whew. I don't know why that's my goodness. Oh gosh. Usually by this time I have it down. All right. Michaela wrote down the interpretation. I'm not going to make you explain it. We basically fill in the blanks, right? We are blank % confident that mu is between these two numbers, and that pretty much does it all. Does anyone have any questions on confidence intervals? Alrighty, then I think what we'll do for the rest of the class is the quiz review. I already put the answers up on my classes, by the way. So if you have somewhere to be, I don't mind you leaving. But if you want me to check your answers, then that's great.